Alright, so this is going to be the third video in my series on vectors. This one's going to be on subtraction and scalar multiples. Subtraction, it's really easy. So all you really got to do is you take your two vectors, line them up tail to tail like this. So we'll call this A, this one B, and the difference of A minus B is C, and C is from the head of B right over to the head of A. Let's see, right there. Pretty simple. It was just something I sort of missed on my last video on addition. I figured I'd let you know about before I got into some newer stuff. Alright, so I'm just going to erase this here before I get on to scalar multiples. So scalar multiples of vectors are a pretty simple concept to understand, I think. So let's say we have a vector A like this, right? And we have a vector B. It's about 3 times as big as vector A, and it's in the same direction. Alright, so we could say that B is equal to 3 A's. It's 3 times as long as A. If we were to draw 3 more vector A's in here, we get the length of vector B. Alright, it's not perfect because it's just a drawing of mine, but you can kind of see what I'm getting at. Alright, so that means that we can have things that are like this. So say we have, this is V, and we'll say this is W. And this point over here, we'll call P, and this is O right here. So if we want to get from O to P, so we get vector OP, we need to add a scalar sum of V and W. So using parallelogram law, we can see that P is that far off of the W sort of axes almost, right? And that is the same as V. So we can make a parallelogram by saying that we need this much more, which is about double of W. So we can say that OP is equal to V plus 2W. Both those are vectors. Alright? And that just lets us get to places. And what that means is we can have things called unit vectors. So we have this little vector right here on this plane that I made. I'll call this one T. It's kind of hard to see. It's vector T right there. And this one right here going one up is vector S. Alright? Each of those have a length of 1, and they have a direction which is 90 degrees to each other. They're perpendicular. Right. So what we can do with these two is then make any point on this grid. So say we have a point out here. We could say that that is 1, 2, 3, 4t plus 1, 2, 3, 4, 5s. And that will get us to point P from the origin, point O. So that equals vector OP. Alright, we can do that for anything. So we can have one down here. Let's say, so we need 1, 2, 3t. We'll call this point J, capital J. We need 3 t's, and we need negative 1, 2, 3 s's. So we can put 3t minus 3s. Right? And that equals OJ. Origin to point J. Alright, let's see how that works. And this is a really important concept, because this means that we can then do Cartesian operations on vectors, similar to what you would have done in a functions class. And that brings me to the point of the next video, which will be on Cartesian vectors. Alright, so I'll see you then. Thanks for watching. Bye-bye.